Welcome to our build series for our 4-inch scale Burrell DCC traction engine kit by Steam Traction World. For this video, we will be showing assembly of Kit 7, the tender. Following the usual cleaning of all parts, the tender sides below the top plate, tank top, front, bottom, back, brake right hand and left hand fittings, brake tube, and axis cover were cleaned and soaked in POR 15 metal prep according to the directions, followed by the POR 15 waterproof coating. This prepared them for the final waterproof coating to be applied later. All surfaces that would not form part of the tender tank were primed in the usual manner. Parts were test fitted loosely before final assembly began. This showed that the plate to form the back and bottom would require additional fitting to match the curves of the tender sides. The reverse curve at the top back of this plate needed both curves bent to a smaller radius. Since our workshop resources are limited, we had to be creative to create a stable anchor point from which we could tighten the pre-bent curves. We began by placing the top back edge of the back and bottom sheet under the edge of a sturdy reinforcing beam at the bottom of our garage door. We had a large diameter round dowel that was slightly smaller than the final desired radius. This was placed against the inside of the curve in the metal sheet, and additional wood shims were added beneath it to raise the sheet off the garage floor. Using a piece of plywood on the opposite side of the curve, we were able to carefully use our weight to slowly form the existing curve over the dowel, tightening the radius closer to what was needed. Owing to the thickness of the metal and the width of the part, this required considerable effort. Fortunately, our garage door at the time was solid wood and very heavy, which helped anchor the end of the metal firmly. Once one curve was adjusted, we flipped the part over and readjusted our blocking to allow the second part of the curve to be adjusted in the same way. The large radius which forms the back sheet into the bottom of the tank was close enough to the desired radius that we felt it would be pulled into alignment easily during assembly. The back and bottom sheet was loosely bolted to the left-hand side sheet with the supplied rivet bolts. One bolt was inserted and loosely tightened near the center of the pieces. Additional bolts were then added, moving outward from the center every few inches wherever bolt holes aligned. The right-hand side was attached in the same way. Setting the tank top and front in place revealed additional fillers would be needed between the front and sides. The front piece was too narrow to fit tightly to the sides near where they attached to the bottom. Pulling the sides tight to the tank top showed that the top of the front plate would fit well. Therefore, a tapered filler needed to be fabricated for both left and right sides. We discovered that the reverse curves near the top of the back sheet were still not fully aligned with the side sheets even after our previous adjustments. We disassembled everything and made more adjustments to the curves in the back sheet. This time we used a combination of scrap wood, a large diameter dowel, and bar clamps to force the metal around the dowel and further reduce the curve radius. Another trial assembly showed we now had only a very slight gap between back and sides at the curves, but slight enough that we thought the bolts would pull everything together. Final assembly was the same process as our test assembly, starting bolts near the center of the back sheet, then adding and progressively tightening bolts toward the ends. Any holes that did not align were left until all other spots were filled and tightened. The nuts were tightened a little at a time along the entire part. Once all were tight, any unfilled holes were carefully drilled out to correct any misalignment, then those bolts and nuts were also added. It is easy to over-tighten and strip the rivet bolts, so we work slowly and carefully to avoid damaging any bolts. It is important to pay close attention to the instructions and provided drawings. Several bolt holes along the sides and back are left empty for later attachment of other parts. Some bolts are longer than others to fit through the back and bottom fillers and both inner and outer sheets. There are other screws that are flathead for the countersunk holes which will eventually be covered by other parts. The right-hand brake tube end was attached to the right side, noting the oil hole must be positioned pointing up. Next, the brake tube was installed with high-strength retainer spread over the end joints. The left-hand brake tube end was attached and the brake tube positioned with an equal gap between each brake tube end and the tube itself. To simplify final waterproofing, we left the tank front off and fitted the tank top next. This allowed us to easily brush POR 15 into all crevices between the panels, which would have been difficult once fully assembled. A minimum of 2 coats were applied, with light sanding between coats. The dummy curved cover was bolted in place and all bolts and mating parts were brushed with a generous amount of the POR 15 coating, allowing 2 coats with proper drying and curing time in between. All other holes were temporarily covered with tape to allow us to test the water tightness of all seams. Water was poured in through the open tank front and any leaks noted. Once the tank was fully dry, additional POR15 was brushed in around any areas that leaked. The divider was bolted in place between the sides. Some of the screws are countersunk to accommodate fittings that will be bolted to the sides later. The tank front panel was also fitted and the left and right filler pieces fabricated to fill the side gaps. Once all bolts were tightened and misaligned bolt holes re-drilled, the tank was tipped forward and POR15 brushed along all front seams. Even with all our reforming of the curves in the back plate, there was still a slight gap between this plate and the left and right sides. This gap was filled with JB Weld, then ground smooth. We assemble the bunker sides and back, and the side and rear straps. The tender beading was temporarily attached to check fit. The tender rear, left, and right beading is applied extra long. After screwing in place, the overlap between pieces was measured and an equal amount removed from each to keep the seam centered. The front L-shaped beading for the left and right bunker sides is applied oversize as well. The excess was carefully marked and trimmed to provide a tight fit between these pieces and the rear bunker beading. There is a gap between the beading at the back corners of the tender and bunker where the back and side plates overlap. These gaps were filled with a generous quantity of JB Weld, then the beading was fastened in place. The JB Weld was forced out of the gap as the pieces were tightened. Once set, the excess was ground away to leave a smooth edge where the gap once was. The front L-shaped beading for the left and right bunker sides is applied in a rectangular profile, as is the U-shaped beading for the left tender side. These parts need to be rounded to match the curved profile of the straight beading parts. A Dremel with flexible shaft and a sanding drum were used to progressively shape the parts until they matched well with the surrounding pieces. Files and various grits of sandpaper were used to finish the sanding and eliminate tool marks. The U-shaped piece was shaped in a vise, with some shaping done with the part attached to the tender. The smaller bunker pieces were shaped on the bunker. To shape the surfaces facing away from the outer edges of the bunker, the pieces were removed and reinstalled 180 degrees around to face these edges to the outside, where it was easier to shape. Once satisfied with the shape of all pieces, all remaining beading was permanently attached to the bunker and tender. After attachment, all bolts were carefully ground off to provide a perfectly smooth surface to the beading, ready for paint. The brass elbow supplied in the kit was polished and clear-coated to preserve its shine. Final painting of the tender became a major problem for us. Initially, I intended to brush paint the tender, but it was clear that painting the inside of the bunker would be difficult. Although we didn't expect a flawless finish, we also didn't want deep brush marks. The paint we had available was not the right consistency or formulation to be considered true coach paint. We attempted modifiers such as the oil paint additive Penetrol by Flood, as well as various thinners with less than perfect results. We decided at this point in the project that all future parts would be painted by airbrushing. It took several attempts to find the best thinner and consistency to achieve a good finish. Our shade of red for the inside surfaces also required 4 or 5 coats to achieve a good color. I later discovered that red paints generally use a clear carrier as the base, unlike some other colors. This requires more coats for a similar color depth. We allowed substantial time for each coat of paint to cure. Some wet sanding was necessary between coats. We encountered an adhesion problem on the back of the bottom, which required sanding down to primer in this area and starting over, carefully blending the area and respraying everything so it wouldn't show. Our best guess is that we missed this area when wiping down the parts after sanding, but prior to the next coat. The paint adhered to the dust rather than to the surface below. With other projects in progress too, painting of the tender took nearly 2.5 years. After the final paint coats had dried, it was time to add the lining. By this time, we had completed our belly tank, so we applied the same technique of using various widths of striping tape to mask off the areas for lining. The appropriate strips of tape were systematically removed and the areas painted. Once set, further areas were exposed for additional colors until complete. Some areas were filled in freehand as well. The toe bracket was temporarily fitted to accurately align the lining in this area. The left and right toe straps and the toe bracket were bolted together once all tape was removed. Additional POR 15 was brushed over any bolts that protruded into the tank cavity. The brass elbow that will connect with the belly tank was installed with a bit of liquid gasket on the surfaces that mated to the right tender side plate. You'll note in the video that the tender was installed to the horn plates and boiler prior to adding the bunker extension assembly. We discovered that there was some touch-up needed to the bunker extension striping, so that was left off the assembly to make the work easier. In the meantime, we elected to mount the tender to the horn plates and boiler to get it out of the basement and out of the way. Eventually, we completed the touch-up work on the bunker sides and mounted that assembly to the tender with the supplied bolts. The tender was finally completed after 3 years and 5 days from when the kit was first received. We certainly were not very efficient dealing with this kit, but many other parts were worked on and completed in between. Although we have completed most of the tender fitting kit, we will hold off on that video a while longer, as a few parts are on back order and a couple still need a bit of paint. Instead, we will skip forward a bit with our next installment in this video series and cover kits 12 and 13, the cylinder and the cylinder fittings.